explain the process of garbage collection in Java. In the previous video, we saw the Java memory management, and along with that also we saw the garbage collection as well. But there were some questions that were unanswered. That is why this video is coming in. So all related questions, whatever were not answered, will be answered in this one. So first, let's summarize the GC process, how it is that. So first one is that marking. So basically, let's say if there is a table of this kind, right, and these are the memory locations, and in this one we have all the objects that gets created, they get the location in here. So right, in this one marking happens. What is those marking? Used and unused, used and unused, these marking happens. The next one is the deletion. So whatever are unused, they will be picked for the deletion, right? Third one is the compaction. The second process that happened, the option of deletion, these memories gets freed from this one, right? But they are still fragments and not available for use basically. So compaction makes these fragments available to be used by other objects that are created in the JVM. So this is all the garbage collection that run. These are the high level steps that are there: marking, deletion and compaction. Types of garbage collectors. First one is the serial garbage collector. It uses a single thread, as name suggests. It uses a single thread for GC. It is suitable for small applications only. Okay. The second one is the parallel garbage collector. That is, it's also known as throughput collector. It uses multiple threads for garbage collection, and it is suitable for big applications, that multi-threaded applications that are there. So this is good to be used there as there. CMS, that is concurrent mark sweep garbage collector. It aims to minimize the pause times by performing most of the garbage collection work concurrently with the application threads. Okay, so what is pause time? It's important to understand, because we saw the garbage collection is also a process, a thread that runs to claim the memory. So sometimes it happens that it interferes with the application threads and it prioritizes garbage collection. In that time, application threads gets paused. So that is what is the pause time of the application thread. So it minimizes concurrent mark sweep. It works along with the application threads. That is why that is how it reduces the pause time. The next one is the garbage G1. That is a garbage first collector. It divides the heap into multiple regions, and by dividing those into multiple regions, it works on those regions, and it claims the memory from which region where most of the garbage is there. That is why its name is coming as the garbage first. So this is the G1 garbage collector. Region based garbage collector is there. It divides the heap into multiple equal size regions, and these sizes can be between 1 to 32 MB of size. So basically entire region is divided, entire heap is divided into multiple regions. It can be 1 MB, 1 MB, 2 MB, 2 MB, or this can be set customly. Otherwise, this setting can be customized, or it can be, otherwise it is done automatically by the JVM itself. It performs garbage collection in a manner that prioritizes regions with the most garbage. That is how the name comes, the garbage first. These are the advantages. Advantages I want to cover in a bit. Let's see the steps, like key concepts that are there. First one is we already saw that it is dividing into regions, and what these regions are, these are the young region, the way that we saw in the memory heap memory area. That is how it is divided. And young region is also divided into Eden and survivor, and survivor is also divided into S0 and S1, and this is the first region, and the second in is the tenured. That is also the, like, this name is old generation as well. So how, whenever the object gets created, it is coming in here. When it survives one garbage collection cycle, it goes to S0, it again survives, it goes to S1, it again survives one more cycle, it moves to the tenured. So in each of the region, those marking happens, right, used and unused. So whichever space has most of the garbage, this G1 garbage collectors moves to that space and takes those memories for other objects in here. So after this memory division, let's see what are the phases that are there. So the first is the initial marking. We saw that, right? So initial marking is there. That is where we see stop the word event that occurs. This is where it marks the roots and objects directly reachable from root objects like thread stacks and stack variables. The second one is the concurrent mark. This phase is concurrent with the application execution. This process traces through the root, traces through the live objects in the heap to identify and mark them. It starts from the root set identified in the initial mark phase. So whatever is identified in the initial gets again initialized and marked in the second phase, that is concurrent mark, and the third step goes into the final marking. This is yet another STW, stop the word event. That is where all the objects that gets marked are live objects and dead objects, and the final step that runs after the marking, we have stopped cleanup that happens. It removes those areas, those objects which are not in use, which are dead. The final phase after this one is the compaction, evacuation that runs. It runs that to free up those memories to be used by other objects that are there. Okay, so that is how G1 garbage collection works. So these are the further advantages of this one, like predictable pause time, concurrent execution, region-based compaction, and adaptive in size. Further, if we have to tune the G1 garbage collection, these are the steps these are the command lines that can be run. XMS can be set to set the initial heap size. XMX can be used to set the maximum heap size, and this is the command to set the pause time, custom pause time. This is the region-based heap size that can be set for this one, which is by default this size can be of the 1 to 32 MB. Okay, so this covers about the G1 garbage collector. This covers all about the G1 garbage collector. Let's move to the next one, that is what are the latest. So we have multiple versions of the Java, and there is a frequent releases around it also. So we have to understand what are the new in the garbage collections that is coming in. So the first in there is the Z garbage collection. It was added as an experiment in 11 and got final production ready in the Java JDK 15. It has a key feature of the low pause time. It works concurrently with the application thread. It is very much scalable, and compaction works very great in this one. The second one is the Shenandoah garbage collector. It was added as an experiment in JDK 12 and got the production ready in JDK 15. It is low pause time. It is also predictable, and it has concurrent compaction. The next one is that we have G1 garbage collector. We already saw this in detail. It was added in JDK 9, and later on it has many improvements. That is how we have better predictability, better throughput, and mixed collection. The next one is the Epsilon garbage collector. It has no GC overhead, and it is very simple because we don't have any GC overhead. It is used in the cases when we want to run performance testing for the benchmarking purposes, where we do not need any GC overhead because garbage collection is running by default. So whenever you are running any benchmarking or testing, that garbage collection might take those threads and all that, and it can interfere with the benchmarking and numbers that are there. So if you have to do the benchmarking and performance testing, set the Epsilon garbage collector for that. Parallel GC improvements. These are the improvements that happen, like parallel garbage collection algorithm, improved startup time, adaptable in size, And okay, so these are the things whatever happened in the latest garbage collection algorithms. And what is the default garbage collector in Java? This is the very good. So when we talk about JDK 8, parallel garbage collector was the default one. JDK 9 and later, G1 garbage collector, that is garbage first collector, got the priority, and it is being used as a in the latest version JDK 22-23 also as a default garbage collector. If you have to check what is the default GC that is being in use, so this is the command that can be used. Just copy this command from here and put in the terminal, and it will give the default GC there. If you have to change the GC, this is how it can be changed: Java -XX, and use is this one, and this is the name of the garbage collector, and this is the -jar, and this is the your application that is running. So you can see the parallel GC, you can name the ZGC in here, you can name the Shenandoah GC, and G1 garbage collector, whatever you need. So that is it that we wanted to cover in garbage collector. I think we have covered a lot. Still, if you have any confusion, any doubt, put that in the comment section. We'll be happy to help you out. That is so. I'll see you in the next one, in the next video with the next question. Till then, take care. Bye bye.